Everyone to our seminar today. My name is John Minto from Mintronics. We are the UK partners with Dlubal and their program RFEM. In a few minutes time I will hand over to Walter Russell of Dlubal, who will be your guide today as we examine the RFEM program and the integrations with Revit, Tekla and Bentley systems, and of course not forgetting BIM. Mintronics are value-added resellers of CAD, design programs, reverse engineering and finite element analysis software. One of the main reasons Mintronics were attracted to the program RFEM from Dlubal is that in today's world it is vitally important that systems integrate, and especially so in the construction industry, because of the BIM requirements. When we looked at RFEM from Dlubal, we saw a superb integrator with other systems, and it is this which gave us the confidence to be their partner in the UK. And the same integrations are on the agenda for today, so I'd like to finish now and I'd like to hand over to Walter. Thank you very much.
Hello and good afternoon everybody. My name is Walter Russell from Dlubal Software. I am Director of Sales and Marketing and with the company for almost 20 years. And today, with the help of John Minto, I'll show you the integration of Dlubal Software, namely RFEM, into other CAD programs such as Tekla, Revit and Bentley. I'll give you a brief introduction into the RFEM design software, which is a general finite element program. We will import 3D BIM models from Revit into RFEM and export it to other applications. During this, a main portion will be to show you which design options we have according to Eurocode. And we will also do some update scenarios while we are doing this presentation. When we talk about building information modeling, we often have to do with programs such as Autodesk Revit Structures. This program especially is of interest because we can get the analytical model which is integrated into Revit directly imported into our analysis programs. We can go in both directions. That means we can start with the Revit model and import it to RFEM, do the structural design and update changes. We can also at the same time use a RFEM model that has been created inside RFEM and export it to Revit. So you can do there, for example, further drawings, overview plans, or use Revit as a platform to exchange with other applications as well, or the entire Autodesk world. And we can update changes in both directions. We will see this live today. Another important application when we talk about building information modeling is Tekla structures. Tekla also has, similar to Revit, an integrated analytical model, which is an idealistic model that only includes the main parts that we need for a structural design. And as similar as with Revit, we can also get this analytical model, do the structural analysis inside RFEM and update changes. So it's more or less again a round trip, but at the same time you can start with RFEM and only end up in Tekla, and so you have a one-way direction. Also here we have update capabilities. Another software I would like to introduce today to you is Bentley ISM, or namely the Bentley Structural Synchronizer, which we also link to, and it is basically the link to the entire Bentley world, because inside the ISM interface you can link to all the other Bentley software, like especially maybe Start, that might be important for the UK, or Tekla again, and Revit. So you have a big variety of exchange options inside Dlubal Software. Another important software is ProStructures, which is also made for steel and concrete, and you can exchange models through the ISM interface with those applications. Maybe it's important to know that all those interfaces come along with Dlubal Software. Once you install it, once you install RFEM, you have the capabilities of exchanging the data with Tekla and Revit, as well as a IFC interface that comes with the software, and the ISM synchronizer is available for download at the Bentley website. Before we go into the live presentation, I'd like to tell you that you have the option to ask brief questions in the questions box that you find at your control panel that looks similar like this picture here, and you can hide and show the control panel by clicking on this red arrow, and then you have a question box where you can write or enter short questions that we'll go through during this session. Next step will be the live presentation, and I've prepared a model in Revit, and we will export it to RFEM, do a structural design, and during this work we'll export it to Tekla and to Bentley and back to Revit at the end. For this I changed to Revit. Be here. Okay. Maybe the other way. Revit, where are you? Okay, Bentley is showing up. We need Revit. Okay, just a second. And I'll start Revit one more time. Here we go. I've prepared a model inside Revit that is including a part of concrete and a part made from steel. And it's not a very big model, but it has everything that we need to basically to show you the interface today. Just one more second. And I've prepared this model. Here we go. Already, so we don't start from scratch, and we have the time to really show the interface and the structural design. Okay, what you see here is a building with, as I said, concrete and steel. I have prepared different views of this model, and you see here this is more or less the main structural parts, and inside Revit we have the option to also integrate structural analysis objects such as loads, or also such as structural analysis members or beams that we can show in there and set up in there. Please note that the structural model has maybe an offset of the real physical model. It's an idealistic model, and the engineer has the option to edit this model. And here in the structural framing or in the analytical BIM section, he can set up things like releases or also offsets of the alignment of the BIM in comparison to the in reference to the real physical location of the member. Also, we have things like support conditions that are already set up, or we have also inside Revit things like load cases and loads that we can apply there. All those software work a little bit different, have different philosophy, and sometimes it's maybe also up to the user what he likes to use more. So for us, I think it is important that we have already the option to really streamline the analytical model inside Revit and grab it from any BIM model and use it for further calculations. Whether you take the loads or the combinations or other properties that you use in structural design from Revit, whether they are there or not, is up to you, or it's up to the application. In many cases, structural programs or analysis programs offer more variety of design and load options and combination options and codes as Revit can do at the moment. So the main interest for us is to get this analytical, I would say, predefined model. Here I have all in all 4 load cases, and I have already entered some loads, so we'll save some time when we work then later with the RFEM software. Okay, the Dlubal interface is available then inside the menu bar of Revit, and I can export import to RFEM or to RSTOP, which is a I would say more simple version of a finite element software which only includes beams, but here we have also slabs and walls, so we will need the complete software RFEM to analyze such a structure in one model. You have the option also to export like one slab or one frame or one beam if you like to. You don't have to work with the complete 3D model if you don't want to. You always can extract portions of a structural models also with this interface. When I start the export, there will be a dialog that pops up, and I have several settings I can choose from. I create a new structure. I have options to handle rigid links that may be or may not be available in the structure, or I can define whether I want to apply loads for the export, and then in this case we read right away the load cases which are available in Revit, and for example use one of those load cases for automatic self-weight calculation. I run the export, and RFEM will be started in the background. It's not open at the moment. It's connecting to the RFEM server, and it will create in the background automatically a new model. And after a while, we'll also be able to view a log file where we find all the details, IDs, and things that are used to export this structure. So now here RFEM is open, and I can see a 3D model that's directly derived from the Revit model. And if it's set up correctly in Revit, I also have here for example, my releases that have been set up. I have my support conditions. I can see my materials and my cross sections that came in from Revit. And we see here also as a comment the original name that has been used for this cross section in Revit. This is a sometimes crucial point because in different countries, in different applications, cross-sections are named just a little bit different, and how to match those. For this, we have the option to use a so-called mapping file, which is available here, or for the cross-section, which is available here, and you can import, export those descriptions from Excel and use them. So there's options to map those cross-sections and material names. Of course, as I already told you a little bit, not all the information that we need might be in the Revit model. So everything that we don't get from Revit, we can change inside RFEM. And for example, things I would like to change is, or what is not available currently in Revit by default, is things like tension-only members. So I go into RFEM and I choose from the options here, I make these tension-only members because this is a bracing and a round bar, and so they act only as tension members. Same thing is with, for example, these slabs, and at the same time you see how we work and edit with RFEM. I'd like to enter here a release and select where this release, on which boundary these releases will be and what type of release it will be. And with a few mouse clicks I can change here the model and edit it as I like. Next to the surface releases, I make a few changes here also with the columns here, which are now fixed at the end, but I don't want this. Maybe the engineer that works in Revit can't even decide whether there is a hinge or not. So I can easily just edit those properties and then add the corresponding hinge information to the beams. Please note, you see here the direction of a member. There's a little arrow, and now you know, for example, at the beginning or at the end, you will have to have this release. Same thing here at the member start. There are a variety of releases available that have partial activity and, for example, free diagram, or there's things that you can enter and change yourself. There's nonlinear properties of those releases available inside RFEM. Okay, I entered here a few releases, and maybe at the end here I can also do a multiple selection and change many properties or the same property on many members at the same time. Okay, maybe we'll take a look at the loads. We see here also the loads that come from Revit. I can also change them, edit them as I like. Of course, in RFEM we have all kinds of typical forces, moments, temperature loads, pre-cambering. They can be of any trapezoidal shape or freely varying distributions. So everything is possible what's typical needed inside RFEM for structural loading. I have 4 load cases: snow, wind, and live load. It is not maybe a complete set of loads, but it's enough, I think, to demonstrate what we can do here, and we also need to make sure we don't take too much time, so we can show this in a concentrated form today in a limited time. You see here also to the left the navigator trees, data, display, views. We'll work with those during this webinar, but basically you can use it as a guideline, because you work your way through from top to bottom, and at the end you get to the modules where you have all the design capabilities from steel, timber, concrete on up until connections, foundations, and so on. So depending on which modules you buy, you get a selection of these modules here in the tree. Everything is intuitive. You click on it and you can edit it, as well as you click on the beam and you can edit it, or on the column, and it's really intuitive way to learn the software. If I don't want to see the guidelines or the grid, I just can hide it. The table here is another way to work with the structure. It gives you a good overview, for example, which cross sections are used where. They are available for each element, each object we have, supports, line supports, surface supports, materials and nodes and so on. If you want to know the coordinate of a node, you double click on it and it right away synchronizes here with the table. Okay. Well, maybe as an engineer that works with several partners, you'd like to hand on the model right away to your draftsman, to your detailing engineer, and we want to export it to Tekla. Tekla is open, an empty view open here, and I would like to export it to Tekla. So I have a few buttons here, import and export to Tekla, and both applications directly link, and I can, for example, overwrite or create a new model inside Tekla. I click OK, and it's a direct link, and so the model is updated here live into Tekla structures. You see here also all important information like thickness of the slab or cross-section information are matched, similar like we do with Revit. The detailing engineer can right away start now to create, for example, some connections. I can choose, for example, a shear plate connection, create a small connection here, which is more or less intelligent. I can put another one, for example, on this end, or I can create one, doesn't matter. So he works basically in his environment. He knows all the cross sections. He can use this model to do some messing, whatever. So we leave that model alone, and at the same time maybe we want to do the same thing with somebody who works with Pro Steel or with Start Pro or with other Bentley software. So we export it to the Bentley ISM environment. The ISM software is basically the link to the Bentley software world. Since they have so many products, they needed one tool, that one database that where every different software of Bentley links to, and so they can integrate themselves or exchange data between their own software. So this is done with this structural synchronizer, and Bentley came to us and asked us, hey, can we link, can we do something? So Dlubal implemented this ISM interface, and it takes a while to start up, and now I can export into this new ISM file. And once it's written, we can use the free viewer, the ISM viewer, which is available on the Bentley page, to look at the software. So you see here a little protocol that runs down, and once it's done, we should have here the ISM file, and I can view it in the ISM viewer. And inside the ISM viewer, will see that model, and now we are already in a Bentley software, and all the Bentley programs can then use this software and work with it. Or you can use it also just for communication and see what is in there, see how this file looks like. There's also things like export to different file formats, or print to a 3D PDF, which is also available in Dlubal. But you have it's quite a good tool also to work with beside the exchange capabilities. Okay, we have this file here, and we'll take a look at that later once we have done some changes. Okay, so we are a structural analysis team, so we want to do some structural design. So I have my cross-section, I have my loads. Next thing I will have to do is I'll have to talk about some design codes, some combinations, and some analysis, some internal forces. So firstly, when I go to RFEM, I have the option to automatically create combinations according to a code. There are many codes in there by default, but we want to do it with Eurocode, so I choose Eurocode EN 1990, and I can choose the British standard. And you see here also we have integrated all the combination coefficients, consequent classes, and so on according to Eurocode. And then I can check I want to do automatic load combinations. I click on it, and now the software knows we talk about Eurocode. We have already load cases, and as I have tables for structural data, I also have tables for load cases and load data. So we have those 4 load cases, and we talk about Eurocode, so we know the action categories that are possible there. And I change it now to, for example, I want to have a storage area as an imposed load in this load case 4. If I show the loading, you see here the corresponding load case 4 and where those loads are, and I say this is a storage mainly. I have then actions, which will be a summary of all the load cases. There can be more wind load cases, more storage load cases, for example, and they are all compressed in actions and in so-called combination expressions, and I just check which design situation I'd like to work with in this project, and I'm interested in the structural design, not so much about deflection and so on, but I want to know the strength. So I'm looking at the ultimate limit state at the moment. And then from this we get the automatic combinations, and we have a set of 13 combinations that are ready for the calculation. You see here also the safety factors, and depending whether there's wind or snow and wind, you get different partial safety factors for the structure, and the software does this automatically. Also at the same time, it is a non-linear second order calculation. This is the default setting, which can be set up differently as you like in the software. Okay, I have here now my combinations. I have the individual combinations, and I have a result combination, which is basically an envelope combination of the entire combinations I created. And if I run the analysis of this result combination, other combinations which are part of this result combinations will be automatically calculated. As I said, it is a nonlinear analysis because we have several iterations. We have, for example, the nonlinear tension only bracing elements in there. So the software checks whether they are failing, whether there's compression, and takes them out or leaves them in, and that takes several iterations to find that out. Also, we have a second order analysis, which means that we have equilibrium on the deformed structure, and it will take a few iterations to find this equilibrium, and the deflection or the drift or the skew that happens in the first iterations will have an effect in such way that there will be additional moments, and it has to come to a stop, so it has to find an equilibrium. And if for example the structure has not good supports or is not strong enough, there will be an instability, and you have to increase columns, beams, cross sections in order to get the right to get a stable structure. These diagrams here show you the maximum displacement, and you see if everything is converging, it stays the same. If it's not converging, it may run away, and it's an indication if there's going something wrong or not. So it's an important information about the iteration process and how things are handled inside the solver. I'm running this analysis on a standard laptop. We don't need any major machine, 64-bit Windows, and I actually have only 6 GB of RAM here, so it's nothing spectacular. Okay, now we have results in the result tables here. We can go through tables of internal forces, deformations in different assortments, in different sorting. We can export, import to Excel. But basically, if I don't need it, I can just close the tables and be done with it. I can use the graphical view. I see here deformations, and I can go through the individual load cases and see what happens. Also, I can, for example, choose from different settings in the display navigator how I want to display this deformation. We can make it a little bit more spectacular like this, and once I have done such a view, I can save it as a view under a name. So everything will be stored under this name. So you see here already there might be some problem with this frame here in the middle, which is lacking this column here, and this is now my internal forces. But I'd like to see where are we regarding stresses. So I'm going down and using the first module. It's called Steel EC3, which does a Eurocode 3 design for steel structures. First, I'll choose the national annex, which is already preset here for British standard, and I have all kinds of national parameters for this design here available. Also default content of this module. Then I need to decide on which members I'll do the design. I'll check all, and I need to decide which combinations I'm going to use for design. I'm using the individual combinations because I'll get the information which combination will be controlling at the end. If I use only the envelope, I get the information the envelope is controlling, but I know that anyway. But if I want to have the individual information, I can select the individual combinations. I have access to the material parameters. I have an overview about my cross sections. I can add intermediate lateral restraints. For example, if you have a long beam, you can say there's intermediate horizontal bracing. I can choose the effective lengths. By default, they are set up for the member lengths. And I can take into account things like shear panels, rotational restraints. So we can take into account the bracing of a steel deck that's on top of the roof, and that's stabilizing the compression flange of an I-beam, for example, which has a tremendous effect on stability, for example. If I only want to see stresses, I can, or cross-section capacity, I can take out the stability and only have a cross-section check, which makes things more simple, and which I'll do now for the first approach. I run the analysis and I see here some results by load case, and I see, okay, there are some problems. I can also go into the overview of the cross-section, see the maximum ratio, and we'll see here also where the problem actually is. You can see here this original beam here, or if I go back, close it, and I change to another display, and I say I want to see my maybe lines here, but no results. Basically only I want to see the selection of the cross section. So I go here to Steel EC3, open the module again, and if I am in the cross section table, I can go through and see, okay, we have here some problems. Okay, this is quite okay. This is also 85% utilization. Here I have a problem with those cross sections. We have here different utilization ratios and so on. Okay, since I know there is a major problem also with these columns here, and it's mainly due to this missing column here, I'll go ahead and change my model, and based on this first initial design, I'm going to decide as a structural engineer I need a new column here, and it should be the same one like here. So I just drag and drop it over, and I have now this column here also in there. And when I do this, everything is remembered. All I have to do is I have to restart the Steel EC3 calculation, and I'll get updated results. It is an iterative process to do this design, to find your first correct cross sections, and after that next we'll do a stability design where we'll do a optimization of the cross section as well. So it will take just a few more seconds to update the results. And yeah, then we can do, as I said, the analysis of the stability as well, and it will go a little bit faster. So I've explained now pretty in detail how things are going, so we'll speed up a little bit, so because it's the same procedure again. Okay, there's only 3 more combinations. If you have a linear analysis, you may be able to solve it in one step, and things will be much faster. Also, as I said, you can use more memory and a faster engine, and things will also be faster. It's not the most up-to-date computer at the moment. We have here design ratio of 93%. If I go back to Steel EC3, things look much more pleasantly, and I say this is my design now, and I check stability for one more time and rerun the analysis. So the design without calculating the internal forces will be much faster, and we see here with the stability check we still have some extra problem here. Here we are okay. Let's say maybe let's go here. Check those cross sections. Those are okay. Those are 79%. Maybe I can get by with a smaller cross section. So I check optimization from the current row from the wide flange beams. We have here now the main beams here. We are slightly over it. So we also do an optimization. Maybe let's find the other one. Here we have 95%. Here we have 75%. We can optimize that as well. Then the columns, 61%. We also optimize those. Here we have quite quite low utilization. These end columns here we also need to optimize, and we have here now the main columns here from the frames we optimize, and the bracing will just leave the same as it is now. Okay, with this maybe I have to talk about one more thing. For those columns here, for those basically 4 columns, we need to take into account that we have maybe a buckling length that's longer than the member length. So how to do this? I go to the effective lengths table and just select in this cross section here or this column here, and I can enter now my buckling factor. I enter here something like 6, which will result in a buckling length of 45 meters. There's options also to get this buckling length from you can measure it basically, but you can also import it from a module that's called RF stability, which allows you to calculate those buckling lengths. Okay, this was one column. We do the next column, and I can just copy, for example, this value with copy paste, and I have basically 4 more columns to do. This one, and copy paste here as well. So I can check it. Seems to be okay, and I run my analysis now one more time, and I have a pretty good idea of whether it's even controlling this buckling in this case. Okay, now we have pretty nice utilization ratios. I go to the cross sections, so quite okay. We have changed cross sections here for the main beams. For the columns should be, oh actually it stayed the same, so it didn't make a difference. Yeah, and we'll have new cross sections. Okay, now the internal forces have been calculated with this previous cross sections and stiffnesses. Since we do a nonlinear analysis, I have to make sure I get those cross sections back to RFEM, so I export them all. Of course, I have to calculate the results one more time because they have to be deleted because stiffness plays an important role. Before we run the analysis, maybe what we can do is we also can talk about the concrete design, and I want to design this slab here. For this I need the concrete surfaces module, which also comes along with Eurocode. It's quite similar. We have here again British Standard, we have here Eurocode. I select, for example, now the result combination. I'll check my materials. I have the surfaces that I can check from, and I have the reinforcement, and in the reinforcement I can check which surface I would like to do the design for. I'm selecting now one slab here. I can enter the concrete cover, top, bottom. I have, for example, 2 layers of reinforcement with the corresponding directions. I can set up a basic reinforcement. For example, I can use diameter 10 millimeters every 200 millimeters, and you get here a reinforcement area of 3.93, and I can put it in on top, bottom, and in both reinforcement directions. After that, I run the analysis, and because we don't have the results, we have to do one more time the analysis of the internal forces. So The same that you have available for the surface design, we have available also for concrete beam design and concrete column design, everything according to Eurocode, and basically you can do also, as you see here, multi-material structures which consist of steel, concrete, also of timber. We have also timber design capabilities. Timber is quite popular now, also in Great Britain, for example, where we have multi-story buildings made from cross-laminated timber structures, and we have a module that's called RF laminate that allows you to do also these cross-laminated timber panels. I can tell you this because calculation is still running. What's next? We'll take a look at reinforcement distribution, and also talk at the end a little bit about how to do the documentation of the design. And of course we'll have to update our models at the end, so we go back to Tekla, Revit, and Bentley. So we're almost there, and then we'll start the design with concrete surfaces. We see here we have a problem. I can filter out the non-designable results which don't tell me anything, and we have here quite high reinforcement. We have the basic provided reinforcement, the additionally required reinforcement. If I want to play a little bit with my thicknesses, I can just in the design module I can change the thicknesses if I want to without recalculating the results in RFEM and do another design. So I'll check a change in the design mode, so until I get more pleasant results as I like them, and once I'm done I can go and show my results also in the graphic view inside or in the RFEM main window. I don't want to see all the structure, so I cut out a piece, this slab here, from the entire structure. I can view it in 3D, and I can also display here, for example, my result values. I have here required reinforcement and the additional reinforcement where needed, or I can do this also at the bottom reinforcement. So you can see here you have a whole set of new navigation trees that you can use to set up your results. What I'm going to do next is I'd like to print such a structure into the 3D, into the printout report. How to do this? Well, if I want to see a picture and create a documentation, I can go ahead and just print to the printout report. Window filling, I can create a new printout report. Click OK. It will ask me for a printout template, and I can select which results I would like to see. Maybe I don't like to see all those endless numbers of the result tables, because I want to see a graphic view of it. I need all the model data, I need the load cases and the combinations, and I also want to see the loads. From the steel EC3 results, I only want to like to see the results by load case, and the rest I uncheck, for example. Also for the concrete surfaces, I would like to see maybe no analytical result tables. Maybe from the reinforcement I would like to see maybe only the total overview and maybe some error messages if they are there. So you have quite ways how to pre-select your results here. If I go back to RFEM, I think everything is fine, and I can save this as some name, type B or template, whatever you like to call it. Once it's done, I'm opening the printout report, and I will get all my chapters that I chose for the printout here. Okay, I have here now, it's basically now it's in German, but that's because I installed it in German, but you can change it anytime you like, and you can change the language, for example, to French, Italian. We're an international company, so if I put it to English, everything will be in English as well. If you want to hide something else, you have again a selection here, and you can deselect parts that you don't want to see. But here's my structure, here's my picture that I just printed, and I have a total of 30 pages, for example, now. Next, I'd like to print some results, for example, or the results on the concrete structure. So I go back and show my visibility by surface. I hide the rest of the structure. Maybe I go in direction C. I show the results, and now I have top result, bottom, and so on. And I have many pictures I need to print. So we have a feature that's called mass print. And in mass print, you can say, I want to print things maybe only 50% of the page in size. I want to print the results of the selected concrete case from the surfaces, and I want to see everything, top, bottom, reinforcement. So there should be actually a set of 4 graphics shown in the printout report. I don't even have to open the printout report each time I'm printing it. It goes to the printout report in the background. The same thing I'd like to do with my internal forces maybe. Maybe I'd like to see the one frame in detail. For example, I can cut out this center frame here, arrange it as I like. I want to see the internal forces, bending moment in different directions, axial forces. I set it up as I like it, and then I say please print, again 50% of a page, mass print, but now I'd like to see axial force, shear force, torsional moment, bending moment of maybe the result combination as an envelope. So I get another 6 pictures. You can print here, if you like to, hundreds of pictures in one run. Okay, once you are done, we can take a look at the printout report, or maybe I want to go back and I have my deformation view. This is a nice picture, something like this I would like to see also. I print this as well. Okay, and once I'm done, I'm opening the printout report and see what I get. So it will read all the results, and now there should be some more graphs in there as I printed them inside. So we have here internal forces, and you can see here we have all the pictures nicely arranged, automatically printed. So you have a nice and attractive printout report, which is the summary of your work, and which basically is some business card of your job, I would say, that you hand out to your customer. And here we have the other results of the concrete design. If you want to see something, you just zoom in, and you can zoom in endless, and you see the results, how they are. You have the option here to create a 3D PDF, a 2D PDF, and a 3D PDF we can create also when we print the graphic directly. Okay, these are the options we have for the the documentation. And one more thing I forgot to do before we update the final results inside Revit and the other software. I changed the cross section or the thickness of the slabs here, and I want to do this in my main model again, so we get the right changes back to the other software packages. So I change here to 300 because I used the 300 here, and I change this to 300 as well. Okay, and I'm done with I can make a final calculation with all the updated results and all the updated protocol. But the focus here was also on BIM and on exchanging models. So I update now my Tekla model, for example. And what I do is I export the model again, and this time I check update existing model. And I click OK, and when I go to Tekla, you will see here this column should appear in any second. It's already here. And we have here the updated Tekla model. If I do undo, redo, we see here the changes that come in, also the cross-section change. And because Tekla is a parametric program as well, you see here the change is also updated automatically with the connection, and all the work that the designer did during the work of the structural engineer in RFEM is kept, and only the sections are changed. So you can parallel basically work on your structures. And if I click here, there should be a different thickness. There's 300 here as well as here, and we have different cross sections also, like here, which is an IPE 100, which maybe is too small. Maybe I want to change it. We can do it anytime and do it the same way as I showed. Let's update also Bentley. File, Export, Bentley ISM. This time I choose the same file as I had before. And after it starts the ISM interface, it will ask me whether I'd like to update or to override the existing structure. And I will choose then update in that case. And inside Bentley, there's also some nice feature that allows me to see also the changes that have been done. I will show this in a minute. Here I choose update existing ISM file, and it will now check the existing model in the database and compare it with the new model, and it will show me the changes in just a few seconds. Here we have the ISM synchronizer, and we see here all the changes in the cross sections that have been done. Hang on. Are visible here. We see here the cross sections and the slabs. And I can now basically select everything and decide, do I want to keep it? Do I not want to keep it? Do I update it? Yeah, and I have the option to decide what I'm going to do with these changes. Okay, now I need to show all, maybe select all. And I can select all and accept all the changes. And when I update the repository, accept all, clear all, accept. Okay, and I can make a change here, and I can say, okay, these are my design first run, and I have all the updates, and then after all we can go through with another application of Bentley, which is the revision manager, which allows you to show the changes in a history. Finally, I also would like to update the Bentley model, the Autodesk model in Autodesk structures, Autodesk Revit structure. And here I have the option to update the importing model from RFEM, and it automatically goes to the update mode. This time I don't need the loads. I only apply it to the structural data. And if you look in the back, it will then automatically also put in the column and make the other changes as similar as in the other software. So take some time to compare both models. We use internal IDs to compare both models, so even if you change the numbering, everything will be kept because there's unchangeable IDs that are used to update those models. So it takes some time to check. And then we see here the column came in, and I can view a log file that has the information of all the changes. So we should have here also the IPE 100 beam and the changes in the cross section. Here, for example, that used to be a 360 is now a 400, and so on. So this is basically the integrated design that I wanted to show you today with Revit, with Tekla, with Bentley, and with Dlubal Software. And I think we have some time to do some questions, maybe, if there are any. And there is one question that says, what about connection design inside RFEM and Dlubal Software? There are, as I briefly said at the beginning, also modules for connection design. For example, frame joints and shear connections and end plate connections. Maybe I show quickly how to do a frame joint connection. So the module for this would be Frame Joint Pro, which is also according to Eurocode. And what you can do here is you set up Eurocode, British Standard. We pick here just the node inside the RFEM model. We select the type of stiffeners, whatever we want to have. Yeah? We can also say we go to the layout mode and leave everything as it is, and export, decide to make the calculation for the envelope, run the analysis, and the layout should be done for this connection. Because I didn't have any results, I have to do one more analysis run. Maybe I can answer another questions in that time. Somebody asked me if there's a student version available. Yes, it is. You can download it from our website. There is a student and college section, and there you can apply for it. It's free. All you have to prepare is or provide is a student ID and a copy of your student ID, and fill out a form that tells you everything what you need to provide, and you can apply for it online. Can you integrate architectural features such as staircases into RFEM? It's possible. Actually, we have also a staircase generator, but it's questionable if you really like to do this inside a 3D model, or if you take a look at the staircase individually. But basically, yes, it's possible. So if you would like to have everything in one model, it's possible also to implement this. I can show you also then, once it's done with the connections, where those generators are. Okay, now we see here the connection that was laid out. There is 4 different suggestions. First one has only just one bolt row on the top. With 2 it doesn't work, with 3 it does. It's the first time it works. So I use this variant that was provided by the layout. I run the analysis and get all my checks. I can get all the design details with all the intermediate results here in the tables. I can take a graphical look. I can take a look at the end plate. I can print this, integrate this into the printout report, and be done with it. Also, you have the option to show this then inside the RFEM main window, this connection, and you see here the connection is also inside here, and it's the true geometry of the connection. Then we have another question that was about buckling lengths. The buckling lengths is a typical problem of engineering doing structural calculations. So for this we have a module that's called RF stability, and in RF stability you can check the buckling modes and the buckling lengths, and you just define which number of eigenvalues you would like to calculate. You have to use a load case as a basis for your load level, because the critical load factor is based on one load case. You could do, for example, the envelope load case as well. You run the analysis, and then you get the buckling modes that we can show graphically. And after that, we can, as a result also, we can get the effective lengths for those compression members. And graphically we can see also the parts of the structure that are failing. For example, the first eigenmode is failing of this column, the second eigenmode is failing of the other column, and the center column. So those are basically the weakest parts against stability. And then the fifth eigenvalue we have, for example, those mainframe buckling. So if I would like to know the buckling lengths now of this column, for example, I go to RF stability, I choose the buckling lengths, and I have to pick my column that I would like to take a look at, which is number 63, and I go to mode 5, which is this one. And then we see here we have a buckling length of about 44.5, and I entered 45. So it's quite good. I have done this calculation for myself before, so I have a good idea about the buckling lengths, but this is how it would work. Okay, I think I'm at the end of the live presentation now, and I'm going back to the main presentation here in the PowerPoint, and I'd like to continue here. Before we separate, I would like to show a few customer projects that we have done with RFEM and RSTOP in the UK area. For example, the Waterside Theatre nearby London, timber project, real nice project, big one. Then Canary Wharf Crossrail Station, an actual real great project that we are doing, and as well as the timber design was done by VHAC, and the connection design of all those connections was done with RFEM in a finite element model with solids. Very impressive models that we got here by customer Timmer's Crane System from Belgium. So it's a real integration project actually, where we got the model from VHAG, they exported it and got it to the other customer, and they did the connection design. So a real life good example how you can work together with Dlubal Software between different companies. And also one famous project is the Eden project in Cornwall, and all those space trusses have been done with RSTAB a long time ago by Miro, which is doing those things worldwide. You find all those customer projects on our website, which I'm like to briefly show to you here. It's available at dlubal.com, and if you go to the customer projects and examples here, you'll see there are those examples and you can take a look at them. You can also download a brochure with some of them. The student version is available here at Student and Colleges. Go here and you have here the application form. So just read what's written there and you can apply for it. We also have a trial version that you can download from the website, which is a 30-day trial version which runs for free for 30 days. And with this, I suggest you go to the page First Steps, where you have all the information how to get started. And a good way to get trained is also if you take a look at our webinars, at our former webinars, there's more information about integration with Revit structure or Tekla or other advanced steel modeling, timber, concrete design. We have a variety of topics, and if you want to download all of it at once, you download this, we call it Offline Training Center, and it's a zip file, and you can run it on your computer and you don't have to be online. All those webinars are also on YouTube, so if you go on our homepage, you find here links to YouTube, where is our YouTube channel, and you find lots of video material there as well. I strongly suggest also to take a visit on our social media blogs, where you can find, for example, useful hints that are blogged every day here, printing, and you get, for example, information about how to print, what to print, all those things that I briefly showed you today are here as well. Okay. This is it from my side. I would like to give John the chance to say some final words before we end this webinar. And John, are you still here? Are you listening? Maybe you're not unmuted.
Yes,
yeah, here we go.
Can you hear me now?
Yes, I can hear you.
Okay. Good. Well, thanks everybody for your time coming today, and thank you, Walter, for running the show. But I will email everybody who's attended with some details about where they can contact Mintronics if they need that. But I also wanted to add that on today's seminar there are a number of existing Dlubal customers. And what I wanted to say was, I mean, you have an existing relationship with Dlubal and nothing changes, even though we are now the UK partner. But what I would ask you is if you have any customers, suppliers or partners who you think might benefit from RFEM or any of the other Dlubal programs, then please contact us. It would be great to hear from you. That's all I'd like to say, but just to thank you all once again. And back to you, Walter, to turn the button off. Thank you very much.
Thank you very much from my side, and have a nice day, and I hope to see you again on another webinar that we'll do together. Bye-bye.